Well, welcome back to ETCS Bites Back. And I thought it would be worth it for all of us to have a good look at subset 26 and what is in the text and try and understand how to read the documents and how to relate them to other information. So I thought I'd start at the beginning with start of mission. And as I worked through, I realized actually it was quite a complicated topic and would take quite a long time. So this is going to be the first part, and we'll follow on subsequently with some other information. So subset 26 is the system fundamentals of ETCS, and chapter 5 looks at the procedures. So we know that the core system specifications are contained in subset 26, and for clarity I'm using baseline 3 release 2 or version 3.6.0 of subset 26. The various chapters in subset 26 look at different parts of the ETCS onboard and its interaction with the trackside. And chapter 5, which we'll be looking at in detail, is the common procedures, primarily where the onboard, trackside and the driver interact. So if we look at the text in section 5.4, which is headed Start of Mission, then we have an introduction which tells us when this procedure may be appropriate. The first option is when the train is awake or is wakened, and this generally means that there is one active cab on the formation, and that is where the driver is located. And typically it is the action of the driver putting in a key, switching on a switch, or otherwise engaging with a system which tells the system that the driver is in that cab and that that is the cab the train is going to be driven from. Another option is that a shunting activity has been taken place using SH or shunt mode, and the driver has finished that activity and selects exit shunting on the DMI, which returns the train to its initial state ready for another mission. So that's another trigger of a start a mission procedure. It can also occur when an end of mission occurs, when that will involve disabling the active cab. Exactly how and when that will then trigger the start of mission will depend, but once the cab is then activated again, it'll enable the mission to start. And the last option is around when a slave engine becomes the leading engine. So this could occur when another cab is deactivated, leading to the loss of the sleeping input, or after a slave engine has been operating in non-leading and the non-leading controls are removed. But we're primarily going to be thinking about when a train is awakened, in other words, when the driver activates the cab, or when a shunting movement finishes, because they are the common ones which we see the start of mission process being undertaken for. So we start with the ETCS being in standby or going into standby, and that is the common situation. Maybe a power on process that's occurred sometime previously, but we are interested in the cab being activated and the interaction between the driver and the ETCS. And so the start of mission process continues with the onboard in standby, and it remains in standby until the end of the process, where the onboard then enters normally another mode, or the cab is deactivated again. Onboards and cabs are slightly different. The onboard is the EVC, the European Vital Computer, and that can either be in a mode or it can be put into sleep if another EVC on the formation is active. Cabs are slightly different. More than one cab can be connected to an EVC, and it's up to the EVC to manage which of the cabs connected to it are active. If there's an active cab connected to an EVC, then that EVC will be in standby and it will be the master EVC for the formation until start of mission complete, when it will then enter another mode and remain as the master EVC. So when we start the start emission process, we need to have some data. And the data that is stored in the ETCS onboard can have three states. Not all fields can this apply to, and we will look at which ones in a moment. But we can have valid, where the stored value is known to be correct, and it can be relied on. We have invalid, where there is a stored value, but the system cannot confirm that it is 100% correct. It may be wrong. Something may have changed, which invalidates the information. And unknown, where there is no stored information available. And this refers to the driver identity, the ERTMS level that the onboard is operating in, the RBC identity and phone numbers, the train data, which describes the formation and its capabilities, the train running number, and the train position. Generally, these need to be revalidated or reinserted after a train has gone into either standby or no power. And if we look at the table at the bottom right, for instance, when a train goes into standby, the train data is set to TBR to be revalidated. But if it goes into no power, that train data is deleted. So when we are considering start emission, we need to understand what was the time that the information was last valid, which would normally be before an end of mission, or it could have been whilst the train was operating with the EVC in sleep. And then if the onboard has been in certain modes, and these are typically no power and standby, and these can lead to either the information being deleted, in which case the data will then become unknown and remain so, or to be revalidated, in which case it is set to invalid. Only if the data has been unchanged throughout all the mode changes will it remain as valid at start emission. So looking at driver ID, if the train has just been in standby, then it will need to be revalidated. However, if it has also been in no power, then the information will be deleted and unknown, even if it has subsequently been in standby and other activities have been undertaken, but a driver ID has not been entered for that EVC and active cab. The next part of Chapter 5 is the details of the procedure. And here we have two ways of looking at the information. The first is through a series of steps, starting with S0, and for each of them there is a description of the requirements. For instance, S0 is about when a desk is open and there is no communication established. And this leads on to the next step, S1, although as you can see at the end of S1, there are options. You may go to E1 or to D2. An alternative way of viewing this information, this procedure, is as a flowchart. And the flowchart is contained in Chapter 5 as well, and it uses the same references. So S0 is at the top of the flowchart, and it's got a summary of the information, but you can turn to the detail in the procedure for more information about the flow through this flowchart. Many people regard this flowchart as pretty comprehensive for start of mission, but if you read on further in Chapter 5, Section 545, this informs us that the flowchart is not all embracing. There are situations where it may not apply. And 5452 reminds us that only the main paths are covered, and then it goes on in 5453 and subsequent sections to describe a number of degraded scenarios and alternative paths through the flowchart or between elements of the flowchart. So in order to understand fully what can occur, you need to look at the procedure table, the flowchart, and the list of degraded situations. But that's not the only place that it is worth looking at. You can also look, and particularly for starter mission, in the DMI specifications, where there is extra information about what is displayed to the driver, what form it takes, and when. So let's start at the top of the procedure with S0. We have a train which is in standby, the EVC is in standby, and the driver activates a desk. A desk becomes open with no communication session established or being established. Then we enter the beginning of the process at S0. Now, this is one where there's a little bit of dubiety about what may happen. If we look in chapter 3, then we have some requirements about establishing a communication session. And that occurs when necessary as part of starter mission, if ordered from the trackside, or if a mode change needs to be reported to the RBC. Now the question here is, if you exit from SH mode, and in level 2 or 3, then in SH you are disconnected from the RBC, does that mode change from SH to SB need to be reported to the RBC? It's not considered as an end of mission. If we look in another part of chapter 5, it details what is an end of mission, and it's not been triggered by the condition G listed in chapter 3. So if it is a mode change that has to be reported to the RBC, then coming out of shunting, the starter mission process will not start until that connection has been established, the mode has been reported, and something has closed the connection, presumably a command from the trackside. However, let us assume that we're taking a simple situation. We have just activated the cab. Let's have a look at what happens next. Well, the next question is about the driver ID. The driver ID is used to record in the juridical recording unit who is operating the train. It's not used for any other purpose, but it is required to be valid before a starter mission can proceed. If the train has been in a mode where it has not been lost or required to be revalidated, then this would not be asked of the driver, but normally the driver is going to be asked to either enter or revalidate the driver ID. And this is done through a screen on the DMI where the driver is prompted to enter the ID number of that they are driving under and to validate it by selecting that identity. That driver ID is not validated in any way in terms of checking it for uniqueness or that it is a valid combination. It is just the ID that the driver chooses to enter. And the display details are all shown in the DMI specification. So now we have the driver ID entered and the driver has validated it. It is now stored within the onboard. And one thing that I should mention, just going back, is that at the bottom of the driver ID screen, you can see there is the spanner, bottom right, the settings menu. And that is relevant because if we look in the flowchart, it tells us in S1 that the driver also can set or remove virtual balize covers. And to do that, they need to use the settings menu. Virtual balize covers are something I haven't covered in any detail, perhaps is something for another talk. So let us assume the train running number has been entered and the validation process has been completed. So E1 is satisfied, and we now move on to decision box D2. And the next question is the level and position stored on board valid? Now, position and level are something that it is important that before we do start a mission, we establish. And so the question is, are they stored valid? If they are not valid, then the driver is going to be asked to enter the level and the train will be treated as having an unknown position. If, however, they are stored as valid, then we have a decision depending on whether we are operating in level 2/3, in which case we need to contact the RBC, or in level 0, 1 or NTC, in which case we don't. If we turn to the DMI specification, you'll see a very similar flowchart. It starts with S0 at the top. It talks about S1, which is the driver ID window, and it has got some sub options of enabling the driver to enter the train running number at this point if he or she wishes, or to use the settings window in order to update the VBC. It then has the same D2 and D3 decisions, and if the stored position is or level are not valid, then it goes to S2, the ERTMS level window. Now, the eagle eyes of you will note that when baseline 3 was updated from baseline 2, and we changed level STM to level NTC, they updated subset 26, chapter 5, and you can see under the D3 decision box 0/1/NTC, but somehow the same list got missed in the DMI specification, and you can see at the bottom of the screen under the D3 box it's 0/1/STM. Now, if the train has not entered no power, or if it has but that no cold movement has been confirmed, then the position and level will normally be valid, providing they were valid before the train went into standby and or no power. So it's normal where trains are operating, if they're not shut down and the power to the EVC is not disabled, then that they will have a valid position and level, and the driver will not be asked to revalidate the level. So we now have a process where if the driver needs to re-enter the level, they will be asked to enter the level and then also confirm if it's a level 2/3 area, the radio network that they wish the train to connect to, and the RBC that should be used. If, however, the train has remembered the level and position, then it will go straight into the process of registering the mobile terminal, and having registered the mobile terminal, contacting the RBC, and once the RBC session is established, then it will proceed. And if that session cannot be established, then the driver will be informed. So if we have a look in the procedure for box S2, if the status of the level is unknown, then the driver is asked to enter it, and we'll look at what they can enter in a moment. If the status of the level is invalid, then the driver will be asked to revalidate or re-enter the level. So when they go to the entry, there will already be the previous level shown, and they don't need to change the level, they can just accept it. Once the level has been entered or revalidated, then if the level is 2 or 3, we go to procedure S3, which is all around the RBC, and if not, we go straight down to the main menu selection. We don't need an RBC connection. So what does the level window look like? Well, it will display at the top the current level, if it has been remembered, if it's invalid or valid. If it is unknown, that would be blank, and it will then list the available levels which can be selected. If the onboard has not been in no power, then it has a list of supported levels. and those supported levels remains valid, and only those will be displayed in the list. If, however, the train has been into no power and it can't be confirmed that it hasn't moved, in other words, cold movement detection is not reporting no movement, then a list of default levels are displayed. Interestingly, whilst one would assume that these levels have to be available in the onboard, in other words, for instance, if you are going to select level 2, you need a working modem, the specifications are not clear on that, and just say that it is the supported levels. And this is described in the DMI specification. So instead of looking just in chapter 5, we also need to consider what is in the DMI specification for this particular menu. And we can see that it tells us that the table of priority of trackside supported levels. This is the set of levels previously transmitted by the trackside to the onboard of those which are displayed, unless, of course, we don't have that or it's not available, in which case the default list of levels configured on board will be enabled. And that default list will normally be the list of levels that the train can operate in, support for levels 2 or 3, and support for various level NTCs. Having entered the level or revalidated the level, if that level is 2 or 3, then the driver needs to instruct the train which RBC to connect. The driver has an option to contact the last RBC, which will be the normal option, particularly if a train has been shut down at the end of a previous mission and then it's restarted. Alternatively, the driver can enter the RBC data using the RBC identity and telephone number, and if necessary, change the radio ID, network ID. For the UK, it is unlikely this will be needed because we will only have one network and the SIM cards in the modems are configured to only connect to that network. But theoretically, it is possible. And so we now get to the next stage, having got all the information, either has been entered by the driver or it's from the stored information, and we have a session with the RBC or not. And D31 is that decision box. If we can't establish a session with the RBC, then the onboard informs, apologies, the box missing there. The RBC informs the onboard that it can't connect to it. And the way it does that is by displaying a really helpful message, which is trackside system incompatible. Really tells you a lot about what is happening. What it really means is that the RBC session cannot be opened. However, if we can establish that session with the RBC, then what is going to be the RBC response? Well, there are a number of options, and some of those conditions lead to options which are defined in the subsets, and others are trackside configuration dependent. There we go. We've now got our trackside not compatible message displayed. I'd forgotten it was on this slide, not on the previous one. So if the session with the RBC cannot be established, then trackside not compatible is displayed. And this could be for a number of reasons. It could be that the radio network cannot be is not strong enough. It could be that the modem cannot connect with that particular RBC. It could be that the RBC identity numbers are wrong, or it could be that the cryptographic authentication keys, which are used when you establish a session between the RBC and the onboard, do not match. And so that's another reason why it might not work. But trackside not compatible doesn't really tell the driver very much. However, they will get an icon showing that the radio connection has not been established and has failed. If the onboard has a valid position stored within its memory, and that's going to be because it hasn't been into no power and with the potential of being moved, then it will report that valid position to the RBC. And the trackside is expected to accept that position as valid. It does raise an interesting question, though, and a trackside behavior may be needed for what if that position is reported as valid, but is not recognized by the RBC that the onboard has contacted. It could be that for whatever reason, the train has moved from one RBC to an area to another. The onboard has not updated the RBC contact details, and so it is reporting a location to an RBC that doesn't recognize that location. So that's something for the trackside specifier and designer to think about. If, however, the train has been into no power at any point or can't report a valid position for some reason, then it is up to the RBC to consider how to respond. And if the onboard reports an invalid position, then the trackside may be able to confirm that this is correct, in which case it will send a message 43, and the position is set to valid in the onboard, and the start emission process can continue. If, however, the position is not invalid or the trackside can't confirm it is correct, then it is also up to the trackside design whether it accepts or rejects the onboard. And here there are two options, obviously. If one accepts the onboard, then the position information stored on board is set to unknown. However, a communication session remains in place, and that can be useful. If the train is rejected by the trackside, then the position is set to unknown and the session is automatically terminated, with the driver being informed. And it's up to the trackside designers and policymakers to decide which option is the best. So what next? Well, we go on to the driver having to make some selections and enter more data. And this is option S10, which is the main menu. And I think at that point is a good time to stop and move on in part 2 to look in detail at this menu.